Hello everyone, if you are new to my channel, don't forget to subscribe it. Now we will see the theorem number 2 of circles. It says that if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So let us see its proof. First of all, we have a circle. Its center is O and it has a chord AB and there is another chord CD. Now this chord AB, it is subtending angle 1 at the center, and this chord CD, it is subtending angle 2 at the center. So we have been given that this angle 1 and 2 are equal to each other. Now we have to prove that these chords AB and CD are also equal. Now this OB, OA, OD and OC, these all are the radius of this circle. So they are also equal to each other. Now we will take the two triangles. First is triangle ABO and another is triangle CDO. In these triangles, this line OB, this is equal to line OD because this is the radius of the circle. This angle 1 is equal to angle 2. This is given to us. Here it is given. And this line OA is equal to line OC. This is also radius of the circle. So now in these two triangles, what we have done is we have proved one side, one angle and another side equal to each other. So these two triangles are congruent to each other, and here we have used side angle side congruency. So now because these triangles are congruent to each other, it means that this chord AB is equal to this chord CD. This is by CPCT, means corresponding part of congruent triangles are equal. So hence this is what we had to prove. We had to prove that AB equal to CD, so we have proved it. So now we can say that if the angles subtended by the chords of a circle at the center are equal, then the chords are also equal. So hence it is proved. If you like this video, don't forget to share it with your friends and also visit my channel. You will find a lot of good videos there. If you like those videos also, then also share them with your friends. Thank you.